Hello everyone, welcome to my YouTube channel. Myself is Shrika and today we are going to discuss about top-down parser. So firstly, we'll see what is top-down parser. Top-down parsing is a method of parsing the input string provided by the lexical analyzer. The top-down parser parses the input string and then generates the parse tree for it. Construction of the parse tree starts from the root node, that is, the start symbol above of the grammar. Then, using the leftmost derivation, it derives a string that matches the input string. In the top-down approach, construction of the parse tree starts from the root node and end up creating the leaf nodes. Here, the leaf nodes presents the terminals that matches the terminals of the input string. To derive the input string, first a production in grammar with a start symbol is applied. Now at each step, the parser has to identify which production rule of a non-terminal must be applied in order to derive the input string. The next step is to match the terminals in the production. Within the terminals of the input string, a compiler parses input from a programming language to assembly language or an internal representation by matching the incoming symbols to production rules. Production rules are commonly defined using back nor form. An LL parser is a type of parser that does top-down parsing by applying each production rule to the incoming symbols, working from the leftmost symbol yielded on a production rule and then proceeding to the next production rule for each non-terminal symbol encountered. In this way, the parsing starts on the left of the result side of the production rule and evaluates non-terminals from the left first and thus proceeds down the parse tree for each new non-terminal before continuing to the next symbol for a production rule. Then we'll see one example. Consider the input string provided by the lexical analyzer in ABD. So the top-down parser will parse the input string ABD and will start creating the parse tree with a starting example or a symbol. The top-down parser will parse the input string ABD and will start creating the parse tree with the starting symbol. Now the first symbol A matches the first leaf node of the tree. So the parser will move ahead and find a match for the second input symbol. But the next leaf node of the tree is a non-terminal that has two productions. Now the first input symbol A matches the first leaf node of the tree. So the parser will move ahead and find a match for the second input symbol B. But the leaf node now of the tree is a non-terminal, that is A has two productions. Here the parser has to choose a production that can derive the string ABC. So the parser identified the A production. Now the next leaf node B matches the second input symbol B. Further, the third input symbol D matches the last leaf node D of the tree, thereby successfully completing the top-down parsing. This is the relationship between parser types. First one is parser. Under parser there are two types. First one is top-down parser and the second one is bottom-up parser. Under top-down parser, again there are two types. Recursive descent parser and non-recursive descent parser. Recursive descent parser. A recursive descent parsing program has a set of procedures. There is one procedure for each of the non-terminal present in the grammar. The parsing starts with the execution of the procedure meant for the starting symbol, and the pseudocode expresses the procedure for a typical non-terminal. This pseudocode is non-deterministic. This is because it doesn't specify the method in which the production of a non-terminal must be applied. In the recursive descent parsing, there may be some cases where we may need backtracking. Backtracking is the scanning the provided input string by parser repeatedly. If run production of a non-terminal fails in deriving the input string, the parser has to go back to the position where it has chosen the production and start deriving the string again using another production of the same non-terminal. This process may need repeated scans over the input string, and we refer to it as backtracking. The parsing table and the parsing program. In this parsing, the parser considers the top of stack symbol and input symbol. Predictive parsers. A predictive parser always knows which production to use. A recursive descent parser would always show or know which production to use depending on the input token. And this is the first for a string of grammar symbols alpha. First of alpha is the set of terminals that begin all possible strings derived from alpha. And then for follow. Follow of A for non-terminal A is a set of terminals that can appear immediately to the right of A in some sequential form. If A can be the last symbol in a sequential form, then dollar is also in follow of A. LL of 1. In computer science, an LL parser is a top-down parser for a subset of context-free languages. It parses the input from left to right, performing leftmost derivation of the sentence. The predictive parser algorithm can be applied to any grammar. This is the model of a non-recursive predictive parser. So, non-recursive predictive parsing is a special form of recursive descent parsing where no backtracking is required, so this can predict which products to use, replace the input string. Non-recursive predictive parsing on table driven is also known as LL of 1 parser. This parser allows the leftmost derivation. The main problem during predictive parsing is that of determining the production to be applied of a non-terminal. Thus, non-recursive parser looks up which product to be applied in a parsing table. A LL of 1 parser will change the components. Then key problems of top-down parser. Top-down parsing determines the leftmost derivation of the provided input string. At each step of parsing, a production of a non-terminal is chosen to derive the input string. The key problem in top-down parsing is to identify which production of a non-terminal must be chosen so that the terminals in the production body match the terminals in the input string. Thank you so much.